video, we're going to do a quick showing of how we are going to do the activity to test and see how good a standard normal approximation to a real data set is. So you're going to want to go to our Canvas page in our assignments, go to Activity 2, how good is a standard normal approximation, and then download our two data sets. I'm going to put them on the desktop so they're easy to find. So you'll save both of these to the desktop. Now we're done with that. And then in SPSS, we're going to open these files. Let's just open one of them and let's see how it goes. So the class temp data, activity 2, is some data that a professor at a different university measured for their students at various times, measuring their heart rate, their gender. I believe one was male, two was female. That really doesn't matter for us. The important piece of data for us is their measured temperature. So the first thing to do is to check and see whether or not this is a normal distribution. So what you want to do is you want to go up to Analyze, Descriptive Statistics, and Explore. Right, this is the same thing we've done for our data sets for a while now. Put temperature in the dependent list. And for the statistics, I want to look at the outliers and percentiles. They might show up a little later on in this activity. Let's look at the histogram because we want to be able to look visually and see if it fits our expectations for a normal data set. Normality plot with tests. The test part is the important piece, and I'll show you which test I care about in a second. Hit continue, then hit OK. It'll pop out a bunch of calculations. It'll tell us our mean, 98.249. We're going to round that to 98.25. Our standard deviation, which is important in the standard normal distribution, 0.7332. I'm going to round that to 0.73. Okay. We have our outliers, we have our high values. Our high temperature is 100.8, 199. If we have outliers, they're going to be in the high end or on the low end, 96.3, 96.4. It's the test of normality that we really want to look at. The Shapiro-Wilk test for normality is particular the SIG, the significance value. If this is higher than 0.05, so 0.05 or higher, we are allowed to, statistically, treat our data set as though it were from a normal distribution. This is 0.233. This is significantly higher than 0.5. If you look at the graph of the data set, right, it has a lot of the pieces we would expect to find for a normal data set. It has this little tail, it grows up, has this big peak hump in the middle, and then kind of tails off to the other side. It's not beautifully symmetric, but we wouldn't expect it to be. Data from the real world is never going to fit this perfectly. Okay, stem and leaf plot and our box plot down here are like what we would expect. We only have one outlier on the top, two outliers on the bottom. Right? The normal QQ plot, if this is truly from a normal distribution, all the data points would lie perfectly on this line. They lie pretty darn close except for the ones at the high and low end. So this thing looks pretty normal. Okay. So if we have a normal data set and we know the mean and the standard deviation, we should be able to know some things about the data. One of the things that the normal approximation tells us is that we would expect somewhere around 68% of the data to be between one standard deviation above the mean and one standard deviation below the mean. So I made a little sheet where I'm going to do some calculations. My mean is 98.25. My standard deviation is 0.73. So the temperature for one standard deviation below is going to be 98.25 minus 1 standard deviation, minus 0.73. 98.25 minus 0.73 is 97.52. Right, so anything that is 97.6 degrees or above is within 1 standard deviation on the low end. On the high end, it's going to be 98.25 plus, or 0.73. Right, so that's going to be 98.98. Right, so anything that is 98.9 or less and 97.6 or above is going to be within this 1 standard deviation. So 98.6 or higher. Right. So 98.9 or lower. Okay. So I need to figure out how many data points this is, and there's a bunch of ways of doing this. One of the most straightforward ways that I can think of is to go back and reorder the temperature from low to high, right? This data is not quite ordered from low to high. It goes up in the males and then it goes back down to the bottom in the females. So let's order this from low to high. We click on the temperature, we right click on it, and we do sort ascending. This will reorder our data from low to high. So anything that is 98.6 or higher, 97.6 or higher, 98.9 or lower is going to be within this 1 standard deviation. Okay. All right. So 97.6 first shows up here at the 22nd data point. So that means there are 21 data points less than 97.6. All right, so however many I have at the top, I'm going to have to subtract off the 21 that are below it. So once we get up to the 1 standard deviation above 98.9, right? That's 111, right? So there's 111 data points that are 98.9 or below, but there's 21 that are below this 97.6, right? So 90, whatever the bottom is, up to 97.5, I have to take those 21 data points away, right? This comes out to be 90 data points. Right? The theory tells me that normal distribution should have 68% of the data between them, but the proportion of the data that I have is 90 divided by the total number of 130 data points. Right, so this is 0.692 if you do the calculation, right, which is the same as 69.2% of the data. That's pretty darn close, right? Real world data, I wouldn't expect exactly 68. Standard normal distribution isn't exactly 68 either, but 69.2 is pretty close. Okay. So that's one way of getting hold of the number of data points in these regions. So for the other regions, you're going to have to figure out if we want the low end, if we want the high end, or where we want to do the calculations. On the low end, we start at 1, count up. On the high end, we figure out where that bottom is all the way up to the end of the data, and so on. Right. The activity will be on the next lab period.